chairman and co-founder of the Data Management Institute and managing principal partner of Twigo Partners International, which is a technology and advisory and consulting firm. And I suppose that I'm qualified to speak on this topic today because I've helped about 150 companies develop, test, and in a few cases implement their business continuity plans. And I've written 5 books on the subject of disaster recovery planning as well. So I hope I can put that experience into some guidance that will be useful today to you, the attendees of this webinar, and that you'll find what we talk about useful in your own planning activities. All right, now the bottom line here, if I can start with the bottom line, is that we're about to have a conversation that nobody in their right mind prefers to have. We're going to dwell for a little bit of time on the dark side of technology, the dependency that we've created within businesses on the proper operation of servers and networks and applications, and on the uninterrupted access to useful data. Now, this is the flip side of all those strategies and plans we developed to advance the business, to make organizations more agile, to increase profitability through automation. Basically, we're going to spend the next 45 minutes or so talking about what we can do if things go wrong with the systems, the networks, and the facilities that we use, how we will handle a catastrophic interruption event. Now, it's a conversation we need to be having, but one that seems to be being put off by a lot of the architecture that comes, for the most part, from the tech industry. I keep seeing articles and paid analyst reports claiming that high availability architecture reduces the need for disaster recovery planning. I was just at a conference on big data analytics in which a vendor was saying that data should be protected in place rather than being copied to a secure offsite location. Now, don't get me started about cloud vendors. The smaller ones, basically managed hosting service providers recasting themselves as online backup or DR as a service vendors, tend to know very little about disaster recovery itself. They've just decided to call themselves cloud services and to deploy maybe some backup software or something to establish their expertise. Now, it was reported recently that Google wants the disk industry to give them hard disk drives with a lot more capacity, but with none of that fancy technology that will actually ensure their proper operation over time. They don't really seem to care about annual failure rates, just cheap capacity to store all the bits, and I find that kind of interesting. And meanwhile, I'm seeing 3 things in firms that I visit on a routine basis. Let me just summarize these last 3 points on the slide. First, data is growing, and it's growing pretty fast. Second, many firms have been so hell-bent on platforming all the new data or virtualizing all their applications that they haven't really spent a whole lot of time, effort, or money to create strategies for protecting all of that infrastructure and data. From where I'm sitting, we're ripe for a data disaster. So what should we do about it? I'm going to give you little 10 pieces of advice in this presentation, and hopefully you'll find at least 1 or 2 of them useful to you. Now, let's just count down. First of all, suggestion number 10. We all need to start taking an inventory of what we've deployed. All of our protection planning, if you think about it, should be founded on a good solid foundation of analysis, where we're at, what are the key business processes we support, what applications and infrastructure support each business process, and what data is being used by those applications and where it's stored on the infrastructure. These are pieces of information that you'd think would be a given, but in most companies I visit today, they really haven't done this kind of analysis. There is no map of business process to infrastructure or to application, and certainly not to data, which is really a scary thing because data is a bunch of anonymous ones and zeros. You don't understand which data is important, which data must always be available, which data you can live without for 24, 48 hours, maybe a week in the event of an interruption event. So instead, you're throwing strategies of protecting the data that are sort of one size fits all, and one size fits all never fits you very well. Data inherits its criticality and its restoral priority like DNA from the business process that it supports. So you kind of need to know the relationship between the data and the business process in order to customize and tailor a disaster recovery or data protection program that will fit your needs. Now, simply put, data protection is one of the 3 key elements of disaster recovery planning or business continuity planning, whatever you prefer to call it. Data protection, you need to protect the data in advance in order to be able to recover it in a timely way following an interruption event. And recovering that data is something that we routinely test when we test our disaster recovery plans. We also test the other 2 elements, how quickly we can rehost our applications, reinstantiate them on a new platform if our building is burned down. And of course, how we will reconnect all our networks, which is really reconnecting users that make our systems purposeful to the systems that we've restored. Now, without a safety copy of data foundationally here, you are not going to recover from any unplanned interruption event. And so it needs to be clearly understood that data protection precedes disaster recovery. It is fundamental to it, and we need to do it right the first time. Now, that leads us to suggestion number 9. The only way to protect data is to make a copy of that data. The problem is that in addition to trying to figure out what data we need to copy, there are a lot of different ways to copy data. And a huge vendor-sponsored debate in industry trade press over the best strategy. I contend that there really isn't one strategy. You're going to be dealing with a hybrid. You're going to be dealing with different applications with different priorities of restore, with different criticality to the organization, and that means that you're going to have different kinds of data with different characteristics of usage that are going to require different methodologies and different techniques for making those safety copies, if you will. Now, you have to determine which protection strategy makes sense at a somewhat granular level, and that's a big hurdle. Some of the factors you're going to have to consider are workload and data characteristics. Right now I'm doing some work for a client on databases, and they're doing in-memory databases, and depending on the kind of database you're talking about, online transaction processing versus online analytics processing, you're going to end up with read-intensive or write-intensive databases. That's going to determine really how much time you can afford, and also the transactional rates are going to determine how much time you can afford to quiesce that database so you can take a snapshot, or so you can do continuous data protection, or so you can make a backup of some sort. Now, there are always a broad range of technologies available for doing the job, and sorting between them sometimes comes down to a simple matter of available budget. I mean, we'd love to be able to do this in a perfect way. In a perfect world, we would. However, you know, one of the gating factors on what techniques or technologies we can choose and apply will be the available budget, not just for the acquisition of that strategy, but also for the maintenance of that strategy over time. You're also going to have objectives, obviously, that you've set when you did your analysis. I summarize them as time to data. How quickly can we restore the company to a paying basis by pointing all of its reinstantiated applications across all of its rebuilt networks to the right data? You know, that's the total enterprise here of disaster recovery. Basically, some companies call this recovery time objectives or recovery point objectives. However you frame it, you have to have these objectives that will help guide the strategy you'll choose. I would also emphasize that ease of testing is something you should pay a lot of attention to. The long tail cost of business continuity and disaster recovery is testing. I mean, it costs a lot of money sometimes to get the right gear, to make the right arrangements for a backup facility, et cetera, but those tend to be, you know, amortizable cap expenses. The real OPEX cost of disaster recovery is keeping the plan up to date with your organization, and the only way to do that is to test it periodically and see if gaps, exposures have crept in due to change. And then finally, you have to consider the complexity of the recovery technique that you're considering and whether you have the skills and knowledge on staff or available to you in some way, whether it's consulting services or whatever, to actually implement this in an effective way. So there are a lot of aspects to this making a copy of data that you might not think about. I mean, it sounds like it's a very simple thing. Just look at the data that you've got, set up a source of media somewhere, and just use a network and copy it. And it's usually a little more complex than that. In fact, you know, one of the values of business impact analysis, which is all that upfront data characterization we were talking about, is that it helps you to set up the criteria for continuity strategy so that, yeah, you know, your objectives. The impact analysis, as you see in the little yellow box is basically looking at the business process and trying to prioritize them, and oftentimes we do that with regard to how much it will cost per hour of downtime for that process. Then you also are trying to catalog the data and the infrastructure assets that are used to support that particular business process. And then based on that analysis, we are going to formulate the recovery objectives, which include a determination of how quickly we need the data back up and running, and what the criticality is of the process that we are trying to restore, and how it needs to be restored relative to the other processes in the organization. And then finally is the recovery strategy. And the recovery strategy takes into account the results of the impact analysis, the recovery objectives that have been formulated, and it looks at what is the budget that's available and what's the testing efficacy of the various strategies that we can deploy to try to resolve the problem of data vulnerability. And we have to make some intelligent decisions, and then we formulate that, we wrapperize it in a recovery strategy. Now, the thing that's important to realize is that your strategy may be a hybrid. It may be different techniques used with different applications and different data. And what you need to do is come up with an overarching strategy that can be implemented in toto if you have a cataclysmic disaster, a facility failure, a disaster with a broad geographical footprint, or that can be implemented modularly or in lesser degrees to deal with lesser emergencies, a disk failure or a flash device failure or a power supply failure, or whatever it may be, something that isn't as catastrophic as a full facility outage. Okay, now suggestion number 8 is ignore the hype. I mean, just turn the noise down. The leading hypervisor vendors say right now that high availability trumps disaster recovery, that you don't need that disaster recovery stuff. You know, they suggest that you simply deploy their software and use mirroring with high availability clustering, and you've dealt with 95% of the potential causes of outages and downtime in your facility. And that may or may not be true, but it's that other 5% that gets wall-to-wall media coverage on the cable news channels, you know, the big facility fires, the nuclear incident that causes the evacuation of a whole town, et cetera, et cetera, et cetera. These are the big disasters, capital D disasters, and I think you ignore the potential for those at your own risk. I also urge you, please don't believe it when somebody hands you a boilerplate plan and says, just fill in the blanks, this is a disaster recovery plan in a can. There is no such thing. Frankly, even disk-to-disk mirroring and a failover clustering is not a comprehensive DR plan. It is, at best, an element, so just don't believe it. Okay, hopefully I don't need to make that any clear. I will note this, that mirroring is a very effective technology, but it doesn't guarantee recoverability. I mean, for one thing, if you're doing mirroring between disks, between 7 to 10% of disks fail annually. And in a lot of companies I go to, they've taken all the disks off of a certain run of disk drives off the assembly line, and they're just sticking them one after another into the trays of drives that are available in their storage array. And the fact is, if there's a manufacturing defect on one disk, it's probably going to recur in all subsequent copies of that disk up to a certain point to where it was detected on the manufacturing line and corrected. So you may end up with multiple drive failures. Secondly, you have to realize that bit errors occur on disk at a rate of about 1 times 10 to the 16th power. That may not seem like much, but that's really 1 out of every 90 terabytes of disk storage, SATA disk storage that you deploy is going to have a non-recoverable and usually undetected bit error on the disk. That can spoil your whole day. I mean, a bit error can just corrupt one little file, and that file may be inconsequential, or it might get into a RAID stripe or into some other aspect of the disk geometry that can actually destroy the entire RAID set and make it unavailable if you're still using RAID. So bit errors do occur. We need to be cognizant of that, and we also need to realize they happen a little more frequently than the vendors like to admit. And then thirdly, mirrors have a tendency to become asynchronous over time. The more data you're moving, the bandwidth becomes a constraint, latency, jitter, all those things factor in, and pretty soon the copy of data that's over on your mirror disk is not in the same state as the copy of data that's on your primary disk. In fact, for every 100 kilometers, if you're doing mirroring over distance, which is called replication, every 100 kilometers you go, you're looking at about 12 read-write operations behind on the destination. So, you know, it's kind of an interesting phenomenon. It can mess with your recovery capabilities. And then finally, bad data is mirrored at the same rate as good data when you do mirroring. So if you got garbage or junk or viruses on your primary, chances are it's going to replicate immediately over to your mirror, and then pretty soon you're out of luck. In fact, that used to be one of the big problems with some of the continuous data protection techniques that are out there that involved a lot of mirroring, you know, what they called point-in-time mirror split imaging. The problem was that a database corruption event usually wasn't detected for 24 to 48 hours after it occurred, by which time all those mirrors that you're creating in a continuous data protection scheme are already corrupt. You know, every 2 hours you quiesce the database, make a mirror copy, and then restart it on fresh disk. Those old disks, each one will have the corruption event on them from that point forward. Okay, and most importantly, some disasters have a greater geographical impact, so you know, your mirrored storage may be consumed by the same disaster event that consumes your primary storage. I mean, if they're sitting in racks right next to each other and you have a bad day, you have a pipe break in the ceiling or something, chances are it's going to fry the whole array and both copies of the data. And then, of course, mirroring is a costly thing. I mean, with legacy storage, you used to require 3 different copies of the legacy gear vendor's rig in order to do mirroring. You'd have one that was array number 1 would be positioned next to array number 2 on the same raised floor, and you do synchronous data mirroring between them. And then you had to have a 3rd copy identical in every respect to the vendor's rigs in array 1 and 2 over far, far away, array number 3, to which you are asynchronously replicating your data over distance. And all 3 arrays had to be from the same vendor. And the software that was used only worked if the arrays were with the same vendor. These were all problems that we had before you even get into the issue of distance replication. And now we're hearing the advent of software-defined storage. Here we're running into a lot of the same problems, which you thought would have gone away when we unlocked or unchained ourselves supposedly from the hardware vendors' hardware. Basically, with some of the hypervisor specified software-defined storage rigs, you need at least 3 storage nodes. 1 serves a quorum role, and you need to use only special nodal hardware that's been approved by the hypervisor vendor. And then you also must have exactly the same hardware on each node, or else the replication process won't work. And then you need to have that SDS mirroring functionality in the software-defined storage software that you've deployed. All this can add up to some serious coin as well. We haven't really broken the chain yet on reducing the cost of storage if we're doing a hypervisor-based software-defined storage solution. Okay, plus, you know, there's a misconception that somehow disk mirroring and replication is easier, less complex than tape backup. And just for your edification, I pulled a couple of different diagrams I've created for my next book on disaster recovery. I thought they're pretty and they're good eye candy, but more importantly, you see how similar they are. It's actually roughly the same number of steps, so there are the same number of activities to do disk-to-disk mirroring and replication in a professional way as it is to do tape backup in a professional way. So anybody who thinks that they're getting off the hook that disk-to-disk replication is easy peasy and that tape stuff is too hard, you need to rethink that a little bit or get real with what's really involved in both strategies. Okay, so that brings us to suggestion number 7. I always say plan for the worst. You know, bad things happen to good data, and you need to be prepared for that. And yes, it looks like it's pretty stilted in favor of the small d disasters when you look at the statistics. Here it says 95% of interruption events are caused by the typical things that occur in your environment, malware and viruses, software glitches, user errors, what I call carbon robot errors, and of course problems with hardware and software glitches themselves. And then you have to understand that 30% of that number is also planned downtime. So the theory is that if we use high availability clustering with mirroring, we can shut down one set of rigs when something happens and it's corrupt, and we just reinstantiate the workload on another set of storage and server, and we're good to go. And that can happen in an active-active configuration, can happen in an active-passive configuration, however you want to do it. But basically what you're really saving to winnow that down is the 30% of planned downtime. I mean, there's a good reason to do high availability, because I can theoretically fail over to my redundant system and use that while I'm doing planned maintenance on the other system. So I've basically eliminated 30% of the downtime immediately. That's a good story by itself, and we don't have to embellish on it. What I think the misconception is here, though, that those other 5% of disasters don't matter. The truth is that those other 5% of disasters, which involve weather events, geological events, maybe some man-made things, whether it's a war or civil disobedience or civil unrest of one sort or another, riots, and of course building fires, floods, things of that nature. These are all issues that, at least on the weather side, appear to be occurring with greater frequency today. And, you know, we had a 1 in 200 year storm event in Hurricane Sandy that hit the eastern seaboard of the United States, and everybody basically consoled themselves that while that was an extraordinarily powerful event and with a very broad geographical footprint, over 200 kilometers, you know, it's a once in 200 year event, so, you know, we don't need to prepare for that out of range kind of emergency. But 9 months later, we had another once in 200 year event. And I don't know if this is global warming, climate change, whatever the heck you want to call it or attribute it to, or we've just been bad people and we're getting punished. At the end of the day, that 5% of disasters do happen, and if you're only prepared for the 95%, you're going to be out of luck as though you don't have a plan at all. So plan for the worst case and be able to implement to the lesser emergencies. That's always my recommendation. Then we get to suggestion number 6, which is it's not enough to make a safety copy, and this is maybe where some of the replication strategies that are out there, the HA strategies, really kind of slam into a brick wall a little bit. You have to move that copy of the data off-site. It needs to be out of the facility where it was born, or else it will potentially be destroyed by the same emergency that destroys yours. And that is becoming increasingly a core value case statement for vendors of disaster recovery as a service, DRaaS clouds, or DRaaS clouds, and clouds generally. You know, the picture I created on the right-hand side is pretty much a summary of the marketing that I read all the time. You note down in the lower quadrant, you know, here's your little data center in a bubble being bounced around on turbulent seas in a lightning-filled dark of night kind of situation. Why would you want to do your data center operations down there when you could be up in the sky where there are birds and sunshine and fluffy white clouds and maybe rainbows and hot air balloons and stuff? You know, bottom line is that however you frame it, whether you're thinking in terms of clouds or DR as a service or offsite storage or you know, traditional hot sites, you need to move your copy of the data out of harm's way. And usually that means that you got to go beyond a minimum of 80 kilometers of distance. And that runs afoul of some of our issues with transporting data over networks. And frankly, I'm not completely sold on all the cloud offerings that are out there. This is a little tongue-in-cheek, but you know, there's a lot of folks out there who are offering themselves as cloud storage providers, and you know, I don't think that they or as cloud backup providers. I don't think they understand anything about disaster recovery, and I don't think that they've actually ever participated in the recovery of an organization. One of my clients, a football team in the United States, was impacted by Hurricane Katrina when it occurred. They'd been using an online backup service, backing up to the internet, which is essentially backing up these days to a cloud. And what the cloud service provider didn't realize was that everybody was going to ask for their data back at the same time, and they had a lot of clients in that geographical area. So they lacked the bandwidth to be able to return people's data back to them in a timely way, and a lot of folks ended up you know, waiting over a year for the restoration of their data. That's unacceptable in most DR plans where I'm involved, and I really think you need to take a very, very hard look at the capabilities of the service provider if you decide to go that route. And that's part of suggestion number 6, which is keep it real. We can't just dream that our need for successful data replication is going to go away. We have to, number one, remember physics. I mean, Einstein is Einstein, and we can't really get around him. Transferring data over a wire is going to be fraught with potential problems, okay? First, there's distance-induced latency. As Einstein pointed out, you can't move data faster than the speed of light, at least not until they isolate the God particle and figure out a way to attach data to it. But I guess you might be able to. But if you go greater than 40, well, actually greater than 80 kilometers, you will drive up data deltas. Over 80 kilometers is 40 miles. And frankly, every time you go beyond that limit, you're going to start accruing latency in the transfer. And that will create differences in the source data and the target data that can impair failover. It can prevent the system from restarting successfully over on redundant hardware in a cloud or in a remote facility. And then there's another factor called jitter, which accrues to moving that data over a shared WAN facility where the routers that are being used, the switches that are being used are actually shared among many, many different clients at the same time, and you become part of a time slicing and buffering kind of arrangement, and that can also add up to greater impairment and greater differences or data deltas between the states of data. Plus, if you have a lot of data to move over distance, it's going to take some time. If you're trying to move 10 terabytes over a T1 or DS1 link, traditional internet speed, it will take over 400 days to move 10 terabytes of data, so over a year. If you're moving 10 terabytes over an OC192 WAN or a 1 gigabit per second MPLS network link that you have in some major cities, that's going to take about 2 hours, a little more than 2 hours. So even if your DRAS vendor is living up to his SLAs, he's delivering on all the promised service levels, he's still at the mercy of the WAN or the metropolitan area network, the MAN service provider. And we need to be cognizant of that. And no, you don't solve the problem by moving only change blocks, or by deduplicating data before you copy it over the WAN or the MAN, or by any of these compression strategies that are out there. Less data to move doesn't mean that the data moves faster if the network is congested. I mean, you look out the window of your office, or maybe you're looking at a major highway. You have 18-wheeler rigs and little smart cars, and they're all stuck in a traffic jam. Which vehicle is moving faster? The answer is neither one. They're both stuck in the same traffic jam. So moving only change blocks may reduce the total aggregate amount of data that you need to move and shorten the volume of data, but it isn't going to necessarily make that data move faster over distance. So suggestion number 5 is a way to maybe circumvent this. Today, with all the clouds that are popping up, with maybe your own infrastructure, your own branch office networks, et cetera, you might be able to go back to a game you played when you were a kid, Leapfrog, and make your replication kind of a multi-hop affair. Make your data copy, whatever that is, a snapshot, a copy, a mirror image or whatever, and then replicate it within 80 kilometers. I don't know why I put 40 here. I was mistaking that for miles, but excuse me, bear with me. 40 miles. Make sure that the next destination is within that limit, and then have it relay from there to another facility that's 40 miles away. Pretty soon you'll get to the 100-kilometer or the 200-kilometer space that you want to get to of distance between the primary and the secondary. Plus, you'll have lots of different copies of the data along the way that you might be able to use to reinstantiate your data sets from lesser emergencies or interruption events. And I think that's kind of the strategy I'm seeing more and more companies embrace. And again, that plays into suggestion number 4, which is don't lock yourself into a single approach. Making a safety copy of data can be accomplished in a lot of different ways. You can do a disk-to-disk copy and then replicate it over distance. That's sort of one service level. You can do a disk-to-tape backup, or just a file system copy if you're using linear tape file system with tape. And then after you cut that copy, you take the tape and you stick it in a FedEx envelope and have it flown over to offsite storage. or over to a recovery facility, or you can go disk to disk to tape, or you can do disk to cloud. Yeah, I mean, there are lots of different ways to do this. Think about the options as a set of different data protection service levels, and then create a strategy that uses the service level that's appropriate to each type of target that you're trying to protect. I mean, it isn't rocket science here, or maybe it is rocket science. I don't know. Okay, and then suggestion number 3, for versatility, think about using a virtual tape library. Now, virtual tape libraries are very old. I mean, people are just beginning to grow into them again because of some innovation from StarWind and a couple of other companies in the whole backup server market. But basically, a virtual tape library began its life, if you look at the little diagram down here. Generation 1 was actually a response to the poor use of tape that was made by mainframes. They used to write just a little bit of data to a cartridge and then eject the cartridge and then insert another cartridge and write a little bit more data there. And it wasn't using the cartridges at all efficiently, and these cartridges tend to cost money in an enterprise tape market. So what they did originally was, to solve that problem, was they created some software that ran on the host, and it chose whatever storage was available. You would define it, and it would set that storage, that DASD, up as a virtualization of a tape library. And it was essentially a disk cache that was sitting in front of the tape, and you'd stack up multiple tape backup jobs over there until you had enough data there to fill an entire tape. And then another piece of software would run that to the tape, and you'd use only one cartridge, you'd use it more efficiently, or you'd use a couple of cartridges, whatever. And that was the original purpose of the VTL. It was software-based, used whatever available storage hardware was out there, and it basically was a front-end cache to a tape library to use the media on tape more efficiently. Generation 2 came out around the time of distributed systems. And it was basically an effort to try to put a system in place that was that would have the features and the capabilities of an enterprise tape library, but not necessarily the cost. And it was a temporary storage location. Usually it was defined as an appliance with a set of disks and its own little server. And it would emulate tape devices so that you do your tape backup, except that the backup was actually being written out to a disk. Cool. And then later on, you could move those images over to a back-end tape library as a separate operation. That would ensure that you didn't have, all this activity going on too long. And then finally, Gen 3 came out, and it's basically whatever VTL becomes whatever the vendor says it is. For a while, we had deduplication vendors who were selling obscenely priced storage arrays that they were calling, VTLs. They were saying, well, you just write all your backup data to this, and we squish it down, and so it doesn't occupy a lot of extra space on the disk. And every drive is like 70 hard drives. And unfortunately, nobody ever got those kinds of numbers out of a deduplication rig, but it didn't stop them from charging like crazy for it, as though it was 70 times the capacity. At the end of the day, though, people kind of lost interest in the VTL, especially when some of the hypervisor vendors started recommending doing virtualization and doing this multi-nodal data replication behind each virtual server host. However, it's come back into vogue, and I credit StarWind with a lot of this. They have basically innovated and produced a VTL that goes back to its old beginnings as a software-only solution, or that you can buy in a small appliance footprint. But both ways, it's leveraging some great technology they've come up with for software-defined storage. And the original VTL was all software, but the industry turned to dedicated storage hardware over the years, and now we've seen people sour on proprietary hardware with all of its fixed capacity and its cost. And the latest trend is, again, to bundle the VTL software with a software-defined storage stack, or to operate the VTL as a virtual machine inside a hypervisor environment, maybe in a hyper-converged appliance. Either way, it makes it extraordinarily easy to deploy your VTL solutions and to manage them in common. I mean, if you're using a software-based appliance, you're basically going to be able to manage all that software wherever it's located from a single pane of glass. Now, software-based VTLs have certain advantages. You can go back to them if you want to, recruit any storage that you have for use as the VTL cache. and you can mix and match storage at different sites, so you don't need identical storage at each location. And you can basically use inexpensive or even used hardware for your secondary or safety copy storage. I mean, you don't necessarily have to have primo tier 1 rigs in order to hold everything. Also, this allows you to set up a nearline copy of your data adjacent to where that data is located, so that you'll have rapid access to discrete files or objects in case a single file or a single object becomes corrupted. So I don't have to go up to my cloud to retrieve a file. I can actually, if I have one of these inexpensive appliances right in the same subnetwork as maybe my cluster of application hosting systems, I can keep my duplicated data right there and replicate that as a separate process without interfering with my production environment out to the cloud or out to a redundant facility somewhere. And you can stage your safety copies to tape or to a cloud. I mean, the back end of these software-based VTLs or appliance-based VTLs allow me to make a safety copy out to actual tape or to replicate it to snap it up to a cloud if I want to do that. And of course, it supports all the different flavors of backup, whether it's backup of file systems or bare metal backups of an entire system image or a virtual machine level backup, or snapshots of databases or incremental or block level change backups. However you want to make the backup, it's really kind of agnostic to the approach that you want to use, although I believe StarWind offers its own approach for its own snapshot technology. And then finally, it's restore agnostic. You can point the data at any flock of disk to restore it. You're not committed to only restoring to the same kind of rig that was taken from. Now, hyperconvergence has kind of mashed up with VTL in this current set of StarWind appliances that are out there where they're selling VTLs as a virtual machine. And basically, you can buy the hyperconverged infrastructure appliance from StarWind that has this VTL software on it. It sort of gives it the personality of an easy-to-deploy, 2U or slightly larger, depending on the capacity you need. I think there are different models here. We'll ask Max about that at the end of today's discussion. And you can deploy StarWind's technology and VTL on any Microsoft host that you may have already implemented as well. So you have deployment options depending on what you need in every particular environment that you've got. And basically, you can go disk to disk, or you can go disk to disk and then write to tape, or you can go disk to disk and then snap up to a cloud. These are all capabilities of the StarWind solution. So you actually have several different data protection service levels with any purchase of this particular kind of technology. And I think the deployment possibilities are really kind of cool. In fact, I emphasize the kinship that StarWind has developed with Microsoft Azure. Now you can get the VTL and stand it up inside the Azure cloud. You can get it in the Azure marketplace if you want to. And you can tier to Azure using physical or virtual appliance on-site tiering or by offloading to Azure storage using technology like Microsoft Store Simple. So there's different ways to deploy this that can take advantage of any number of strategies that you may have in mind. The basic that you want to pay attention to is 3-2-1. It's popular backup philosophy in case you've never heard of it. 3, you make 3 copies of the data on at least 2 kinds of media with at least 1 copy stored offsite. And that's a good, sensible strategy any way you cut it for implementing data protection. Okay, we're closing in on the end here. Suggestion number 2 is remember that the restore speed is going to be more important than the backup speed. So your restore rate needs to match your business process time to data objectives, your restore priority. And you're going to need multi-layer protection for mission-critical data, something that will restore you very rapidly for one kind of disaster, and then we'll get back to a working state from a disaster with a broader geographical footprint. You just need to make sure that all the strategies you deploy can be managed and tested with ease. Data protection provisions, in my humble opinion, should include archiving. You should always make sure that archive is part of your strategy. I know it sounds like it's off base. We're talking about data protection, so why are we talking about archive? The truth is that if we migrate data into an archive that isn't being accessed or updated with any kind of frequency, we free up our primary storage space and save ourselves a lot of money with the storage that we need to buy next year. That money that we're saving can actually pay for our entire data protection strategy. It also puts you in good stead with your regulatory compliance requirements and with your data retention requirements over time. So archive is always a really good idea, and it can be built using the same infrastructure that you're using right now for data mirroring or replication, to be very clear. Okay, and all data optimization techniques need to be considered. So don't count out tape. I mean, and certainly don't count out the technologies that I didn't mean to diss them before. The data deduplication and compression, they have a role to play. Just use them judiciously. Make sure that the data that you're optimizing with data reduction, that it isn't, the side effect of that isn't that it takes longer to restore that data to a useful form, or that it will put you in bad stead with the regulators from a compliance standpoint. Just check into that with your auditors if you have any question, and then squish away. Do whatever you need to do to make that data as small a footprint as possible. And then finally, suggestion number 1, don't wait. Get going now. The world doesn't need yet another data disaster, neither do you. And the time to start, frankly, is right now. We have some time, I think, not a lot, but we have a few minutes here for questions. Max, I turn it back over to you, and thank you, everybody, for hanging for the last 45 minutes.
Okay. John, thank you for an excellent presentation. And first and traditional question for our webinar, can I please get a copy of this PowerPoint presentation if possible? John, will you share it with people?
Of course. In fact, I believe you are posting it over on your site, and if people would like to download a copy, you have my full permission to let them do so.
Okay. Awesome. And please keep in mind we will also have a recording available up on YouTube, and you'll be able to view it through StarWind's website, I think tomorrow. Yeah. And right now it's a perfect moment to ask John or myself any questions you may have during the webinar. And we already have a few questions, John. So I guess first one is more of a religious question, or a question of choice. Is it a good idea to tier backups to store part of them in a public cloud?
Is my idea to store my safety copies?
Is it a good idea to tier backups to store part of them in a cloud?
I think that if you have a cloud that's reliable and accessible to you, that there's no reason why you can't do that. More and more of the companies that I go to today are looking at a hybrid cloud model, where they're using some public cloud services, and they're doing a lot of it in their own data center as well. And they, where it makes sense to use a cloud, they use the cloud. Where it doesn't make sense to use a cloud, they don't. Certainly, if you're putting any of your recoverable data up in a cloud, you want to encrypt it. Especially if it's mission critical. Also, I prefer, quite frankly, in order to have access to it, depending on the nature of the data, I probably want the cloud service provider to be able to deliver it back to me on tape. Only because I don't want to wait forever for a restore that's going to take potentially hours or days following a disaster from a cloud. Also, I can't really rely on the network interconnect being available. So anyway, the long and the short of it is, if you're going to use a cloud, you use it judiciously. Make sure you encrypt as a security hedge, and make sure that it's the right kind of data that you're putting out there. If you're smart, you'll probably have multiple redundant copies in different locations.
Yeah. Great. And I would just add to that these days, let's say Microsoft Azure allows customers to get their data back either on a hard drive. You send them your hard drive, they will write your data to it and send it back to you. And that goes for a flat fee. So if you have a light and really capacity intensive hard drive, that's a good idea to do your restore. And it will be a little faster than tape, actually. Now, second question from our attendees. Which is better, disk to tape or disk to cloud backup scenario? So I guess that's...
I don't think that... I don't think there is a one that's better than the other. I think that tape always struck me as being the better strategy only because I have greater control over it, and I'm a control freak. But if you're comfortable entrusting your data and your future to a cloud, it's better to have the copy up there than to have no copy at all.
Yeah, absolutely. And I would actually combine these two together to make critical virtual machines backed up to both tape and cloud. So if something goes dramatically wrong, you have a copy somewhere out there. So I know I've referred to that cloud, but I'll just refer once again. Azure allows to keep the data in multiple geographical locations when you store the data. Well, you actually write the data once, but it automatically gets replicated between different locations. So the more important your data is, the better it is to spread it.
Yeah, my only concern about the cloud stuff is that many companies are simply entrusting their backup process to a cloud or going to a DRaaS service provider without even knowing the physical location of their facility. And if you're doing this across an MPLS network in a football city, a major league football city, you're going to end up with the potential to have the data center where your data is being copied to, the cloud, if you will, which is actually a physical data center somewhere, being right across the street from your own facility, which doesn't help you very much if there's a hurricane that hits both. So know where the data center is that you're replicating to, and know that you have alternate paths to get your data to and from that location, and you'll do all right.
Yeah, absolutely. So as there was a good joke on the internet, the cloud doesn't exist. It's just someone else's computer. So use it judiciously, as John said.
That's right. Actually, I saw one the other day that I thought was equally apropos. It said that there aren't 4 different or 5 different kinds of storage. People have started seeing these slides that say hard disk, SSD, optical disk, tape, and cloud. Cloud is not a form of storage. Cloud is a service delivery model. What the cloud uses is tape and disk and optical and flash and whatever we're using in our data center. There's nothing unique about a cloud. It's just a different source.
Yeah. And we got one more question from our attendees. I guess this one is more towards StarWind. Is StarWind Virtual Tape Library a virtual product, or it is available as multiple offerings? Yeah, so technically that's exactly what it is right now. It's available as both on-premise software. It is also available in the Azure Marketplace, and we have recently released it as a fully functional hardware appliance. So we decided to take a storage-intensive route and deliver a pre-built VTL solution which can provide up to 1.5 petabyte of compressed space in just 2-unit form factor. So there are wide varieties of options you can go with StarWind's virtual tape library. And of course, if you have any questions regarding your particular scenario or pricing, feel free to reach us at sales@starwind.com or on the phone. You've got the numbers up on the screen. We'll gladly help you with your implementation. And John, thanks again for an excellent presentation. I guess we'll be wrapping up the event now. And thank you everyone for coming over today. I hope that was an interesting event for you.
All right. Thank you. And thanks to everybody for attending. Goodbye.
Goodbye.